Hi everybody. Today we shall move on to the last part of solid states, that is classification of solids based on the magnetic property. Based on the magnetic property, the solids are classified into many types like diamagnetic substance, paramagnetic substance, ferromagnetic substance, ferrimagnetic substance, and antiferrimagnetic substances. So these are all the classification of solids based on the magnetic properties. A substance exhibits the magnetic property due to the motion of charged species. We know that any charged species, if it is in motion, it experiences some magnetic field. Here, electron is a charged species, so it can travel, that means it can show either orbital motion or it can experience the electron spin. Due to the electron spin and orbital motion of this charged species, the solid said to show the magnetic properties. So let us take first, that is diamagnetic solid. Diamagnetic solid means the substance which is weakly repelled by the magnetic field, that is external magnetic field. They are called as diamagnetic substances, and the behavior of this type is called as diamagnetism. Example for diamagnetic substance are sodium chloride, titanium oxide, zinc oxide, KCl. These are all example for diamagnetic substance. Here, why these do not show magnetic property is because they do not have any unpaired electron. Due to the absence of unpaired electron, as there is no motion of charged species, they cannot show the magnetic properties. Nextly, paramagnetic substance. If we take paramagnetic substances, the solids which are weakly attracted by the magnetic field, they are called as paramagnetic substances. We may take the oxygen, nitrogen oxide, nitric oxide, cuprous oxide, titanium oxide, and these are all examples for paramagnetic substances. Here these substances shows magnetic property, that is due to the presence of unpaired electron. Due to the presence of one or more unpaired electron, these substances shows paramagnetic properties. Nextly, we shall move on to ferromagnetic substances. The substances which are strongly attracted by the external magnetic field and they can retain the magnetism even after the external magnetic field is removed. They are all called as ferromagnetic substances. Example, the metals like nickel, copper, iron, cobalt, and European oxide and chromium dioxide. These are all the example for ferromagnetic substances. These chromium dioxide is used for the manufacture of magnetic tapes in the cassettes. This is regarding these ferromagnetic substances. Here, these ferromagnetic substances shows strong magnetism or ferromagnetism is due to the alignment of domains in unidirection. So here domains means these are the small volume of solids, those are having a dipoles, those are having a dipole, so they are called as domains. Those domains which can interact with the external magnetic field, they are all called as domains. Here domains means all these domains are oriented in unidirection. You can take here all the domains are oriented in single direction. Therefore these are called as ferromagnetic substance. Therefore, this is the reason why they exhibit ferromagnetic characteristic. Nextly, we shall move on to the mechanism involved in ferromagnetism. Before the external magnetic field, the domains are arranged in different directions. Domains are arranged in different directions as shown in the diagram. As we take the external magnetic field near to it, so these domains will start align in single direction. Then they will align to a single direction. Therefore, they exhibit ferromagnetic characteristics. So nextly, we shall move on to antiferromagnetic substances. Antiferromagnetic substances means the solids which are expected to have very high magnetism, or the solids which are expected to show either para or ferromagnetism, as they are having unpaired electron, but they show net magnetic momentum 0. They are all called as antiferromagnetic substances. That means even though they are having unpaired electrons, they do not show paramagnetism as well as ferromagnetism. That is because here equal number of domains are oriented in different direction. Equal number of domains are oriented in different direction. Therefore, they shows antiferromagnetism. The example for antiferromagnetism are these MnO, MnO2, Mn2O3, NiO, CO. These are all the example for antiferromagnetic substances. Nextly, we shall move on to ferrimagnetic substance. Ferrimagnetic substances means the solids are expected to have high magnetic moment due to the presence of more number of unpaired electron, and they show very low net magnetic moments. Very low net magnetic moment. They are all called as ferrimagnetic substances. Example, we can take the magnetite ore or all the ferrites. Ferrite means here these are M in +2 oxidation, any metal in +2 oxidation, and Fe2O4. The ferrite which are in this form, all the example for ferrimagnetic substance. We can take Zn Fe2O4, Mg Fe2O4 are all example for ferrimagnetic substances. Here the ferrimagnetism is due to unequal number of domains are oriented in same direction. Here we can see unequal number of domains are oriented in same directions. Therefore, they exhibit ferromagnetism. Nextly, we shall sum up all the things we have studied it. That is diamagnetic substance, paramagnetic substance, ferromagnetic substance, antiferromagnetic substance, and ferrimagnetic substance. So diamagnetic substance means it is the magnetic substance which is weakly repelled by the magnetic field, is called as diamagnetic substance. Example, we can take the benzene, sodium chloride, titanium oxide, and all. The alignment of the domains is as such. Nextly, we shall move on to the paramagnetic substances. Paramagnetic substance, information that they are having absolutely unpaired electrons and they are weakly attracted by the external magnetic field, but one thing is they cannot be permanently magnetized. They loses their magnetism when the external magnetic field is removed. Here the paramagnetic substances, the domains are arranged in this manner, that is similar to the unidirection but not in unidirection. Example for paramagnetic substance: O2, vanadium oxide, cuprous oxide. These are all having unpaired electron. If all they are having unpaired electron, then definitely it is a paramagnetic substance. Nextly, we shall move on to the ferromagnetic substance. If we take the ferromagnetic substance, means it possesses very strong magnetic moment, or it is strongly attracted by the magnetic field. One more thing is it can make a permanent magnetism. Paramagnetic substance can show a permanent magnetism here, permanently magnetized. But the ferromagnetic substance can be permanently magnetized, but paramagnetic substance cannot be permanently magnetized here. In this ferromagnetic substance, all the domains are distributed or aligned in a single direction. Nextly, these ferromagnetic substances can be converted into paramagnetic substances above certain temperature. Such temperatures are called as Curie points. The example for ferromagnetic substances are iron, nickel, cobalt, chromium dioxide. These are all the example for ferromagnetic substances. Nextly, antiferromagnetic substances. Here, these are the solids expected to show very high magnetic moment, but they shows zero magnetic moment. Here, because the domains, equal number of domains are oriented in opposite direction, therefore the magnetic moment cancels out. Examples for the antiferromagnetic substances: Cr2O, cobalt oxide, that is Fe2O3, hematite ore. These are all the example for antiferromagnetic substances. Ferrimagnetic substance. Here the ferrimagnetic substance means it is the solid which is expected to have high magnetic moment, but it shows very low net magnetic moment because unequal number of domains are oriented in same direction. Examples for this is all the ferrites of the form M2 plus Fe2O4 is an example. Next, you can take Zn Fe2O4 or Mg Fe2O4, all the examples for the ferrimagnetic substance. This completes solid state. In our next video, we will go through the JE level things in the solid states. Thank you.